We've literally all been there, right? You reach for your phone and boom, flashing low battery indicator. As our digital products get packed with more advanced processors and constantly sync in the background, our battery backup time is, well, it's constantly taking a hit. It's exactly why we've seen this massive surge in the need for portable power banks. But have you ever actually stopped to think about the underlying engineering inside that life-saving little brick you carry around everywhere?
Welcome to This Explainer. Today, we're diving straight into the internal engineering revolution that makes all our modern, sleek, and universally compatible portable chargers possible. We're going to explore how the industry is completely ditching complex software and bulky hardware in favor of a much more streamlined, firmware-free USB-C power delivery system. It's a really fascinating shift, and honestly, it changes everything about how our devices get charged.
Okay, let's dive into this. Here is our roadmap for today. First, we'll cover the portable power need, then the USB-C charging dream, the microcontroller nightmare, the firmware-free solution, and finally, shrinking the circuit board. All right, starting right off with Section 1, the portable power need.
So, as Circuit Digest points out, our modern dilemma is actually pretty simple. The features of our digital products are growing enormously, which obviously triggers us to use our smartphones way more often. And because of that, battery backup time is inherently decreasing. To counter this, everyday users and DIY electronics enthusiasts alike have to rely heavily on emergency spare charging sources, like power banks, just to keep these high-drain systems running without interruption.
Moving right along to Section 2, the USB-C charging dream.
Listen, if we're going to rely on external power banks, we absolutely want them to be universally compatible. We do not want to be carrying around 5 different chargers. That brings us to USB power delivery, or USB PD, which is a universal charging standard. The massive benefit here is that it entirely removes the need for proprietary adapters. Plus, it delivers significantly higher power for fast, super convenient charging. It's basically the dream scenario. One single cable to charge them all, incredibly fast.
And hey, this isn't just about your smartphone. A huge variety of power-hungry applications are rapidly transitioning away from legacy USB ports and those old-school barrel jacks, moving straight to standardized USB-C PD. We're talking about wireless speakers, high-capacity power banks, even heavy-duty power tools. The entire consumer electronics industry is standardizing around this one incredibly efficient method.
Which brings us to Section 3, the microcontroller nightmare.
To really appreciate this tech revolution, we kinda need to understand the massive roadblock engineers used to face. In the past, adding a USB PD port was a huge engineering headache. Legacy setups needed 2 completely distinct integrated circuits, or ICs, an independent USB PD controller and a separate battery charger IC. The issue? Well, these 2 chips couldn't naturally talk to each other at all. They had to be bridged by an external microcontroller, an MCU, which acted as this heavy-lifting middleman. This middleman basically created a super inefficient game of telephone. Think about it. Step 1. The PD controller negotiates a new power contract when you plug something in. Step 2. The microcontroller has to step in, wake up, and read that specific information. Then, Step 3. The microcontroller goes over to the battery charger to update its current and voltage. It was just a tedious, constant communication loop required just to get a battery to charge safely.
And it was a total nightmare for developers. This frustrating process meant writing custom firmware, compiling code, and scripting out complex functions. Hardware engineers were literally being forced to act like dedicated software developers just to make a physical battery charge properly. It was a massive bottleneck that cost so much time, money, and, let's be real, a lot of engineering sanity just to sync charging events.
Thank goodness for Section 4, the firmware-free solution. So, the engineering world finally came up with an incredibly elegant hardware-based fix. Texas Instruments introduced a setup pairing their TPS25750 USB PD controller with the BQ25792 battery charger. The absolute magic here is that the PD controller adds I2C host support. In plain English, that means it can directly control and talk to the battery charger. No external microcontroller needed. The middleman is fired. The chips just talk directly to each other to update everything on the fly. But wait, it gets even better on the software side. Instead of writing hundreds of lines of complex C++ code, you configure the whole thing via a web-based graphical user interface. You quite literally just answer a few multiple-choice questions about what voltages and currents your system needs. That's it. Absolutely no code compiling required. This brilliantly simple approach slashes firmware development time to 0. You really don't need a computer science degree anymore to build a modern, fast-charging device. And this brilliantly illustrates the night and day difference when we look at devices up to 45 watts. The integrated TI solution requires zero external MCU, whereas the old legacy system absolutely did. For firmware, you're just using a simple Q&A web interface instead of complex coding. And finally, the power paths, specifically the field effect transistors, or FETs, are integrated right into the new chips instead of needing separate external components. It's just a total streamlining of the whole shebang.
All right, final stop, Section 5, Shrinking the Circuit Board.
So by pulling all those system field effect transistors, the FETs that manage the actual flow of power, directly inside the integrated circuits, and dropping that middleman microcontroller entirely, you end up saving a massive amount of physical real estate on the circuit board. You're literally erasing physical components that used to take up precious space inside the plastic shell of your gadgets.
To put that into perspective, the old, clunky, non-integrated legacy setups needed a footprint of about 150 square millimeters. That is a pretty huge chunk of board space dedicated entirely to managing the charging logic, and that's not even counting the actual battery cells themselves.
But check this out. By utilizing this new, firmware-free, integrated approach, that footprint shrinks down to an incredible 55 square millimeters. That's a nearly 65% reduction in size. This physical shrinking is the exact reason why our modern portable chargers, wireless speakers, and gadgets are getting so much sleeker and thinner, while somehow packing in way more power than ever before. And what's really amazing is that inside that tiny 55 square millimeter space, you get seamless, bidirectional power, meaning the system can both source and sync power. You can plug the power bank into your laptop to charge the bank up, and then later use that exact same port to dump fast charging power right into your smartphone. It handles two-way universal fast charging effortlessly, completely without a single line of custom code holding it all together. We've seen how removing complex coding, firing the middleman microcontroller, and integrating the power paths have completely revolutionized how engineers build portable power. It's faster to design, way smaller to build, and infinitely easier for us to use. So I want to leave you with this provocative thought. Now that you don't need to be a software engineer to include universal fast charging in your projects, what will you power next? Thanks for joining me on this explainer, and keep learning.